Okay, so 18.4 is talking about the volume of spheres. In this section, if we had time in class, I would show you that the volume of a sphere is derived, well, one of the ways to derive it at least, is by looking at a cylinder with a cone removed and with the height of the cylinder being the same as the radius of the cylinder, so that both of those would have the same value, and then you could replace them for each other. So that the cylinder with the cone removed would be 2/3 pi r squared times height, because the volume of the cylinder of the cone is going to be 1/3 pi r squared times height. Therefore, if we remove it, then it'll be 2/3 pi r squared times height. And then if those two radii are the same, then you could say this is 2/3 pi r cubed, which actually ends up being the volume of the hemisphere, which is half of a circle. And then if it's half of a circle, we could take this and multiply by 2, and then we'll end up getting our volume of our sphere, which is what we're going to actually use today. So our volume of our sphere is 4/3 pi r cubed, and a hemisphere is going to be 2/3 pi r cubed. So all you need is the radius, and you can find the volume of your sphere very easily. So let's look at this example. Once again, we're not going to worry about filling it up with how much stuff we have. They're going to try and make you do extra work by telling you the diameter instead of telling you what the radius is. Well, if the diameter is 72 feet, then our radius is going to be 36 feet. And we need to figure out what our volume is, so all we do is just plug that into our formula. So the volume equals 4/3 pi r cubed, that's 36 cubed, and then all you need to do is just put that in your calculator. So let's go ahead and do that. So you can do 4/3 in parentheses like I'm doing here, and then I'll probably leave it in terms of pi, so I guess I'll just leave the pi out of this. 36, or maybe we'll do the pi afterwards. I don't know. So we'll do that, and we'll say that's that number, and then we'll multiply this by pi. So those will be our two answers. So we either have 62208, so 6,208 pi, or we have around 19,532, so 195, 432 cubic feet cubed. So there you go. Let's go on to this next one here. It says that a spherical water tank has a diameter of 27. So here's our sphere. Here's our diameter. This is 27. We'll go ahead and cut that in half to figure out our radius. 27 over 2, that's going to be 13.5. So 4/3 pi 13.5 cubed, pi r cubed. Cubed times pi. All right, so those are going to be our two answers there. So we either have 2,929 pi, maybe 0.3 pi meters cubed, or 9,202.77 meters cubed. It's just the nearest liter actually, so I guess we'll say that pi, and we'll say this 3, so 9,000. There you go. What we really care about is composite figures. So in order to determine the volume of these figures, we need to figure out what they're both made out of. So in this case, we've got some ice cream cone shape. So we are going to figure out what a hemisphere plus a cone is going to be. So we're going to write down this is going to be, so it's important for us to write down what each of our figures are. So this is a hemisphere plus a cone. So the volume is going to be, nope, not 4/3, 2/3 this time. 2/3 pi r cubed, which r is our radius of 5, so 5 cubed, plus our volume of our cone, which is 1/3 pi r squared times height. So we have 1/3 pi, our radius is 5 again, squared times height, which is 13. And then we can just multiply that all out together. So I'm going to just put this entire thing into one step here, or one equation. I'm just going to not write it in terms of pi because this is going to be a messy one anyways. 5 squared is 125, so we're going to skip a step there. And you may think 1/3 and 2/3 we could add these together because they both have a pi. However, these numbers are not the same, so it's 5 cubed and 5 squared, so you don't want to combine those together. 25. 5 squared is 25. 13. All right, and that gives us 602.13 centimeters cubed. Well, let's look at our directions. Maybe we had to round or something to the nearest centimeter. Cool. So we'll just say this is 602 centimeters cubed. All right. Why don't you go ahead and pause the video, try this one yourself. It's a cylinder with a hemisphere carved out of it, and it says that the height is if the bottom of the hemisphere is tangent to the base, then that means that this length and this length is going to be the same because this is tangent. That means it's just touching it at one point. So go ahead and try. Okay, so our radius is going to be 3.5. Our height is going to be 3.5. So let's go ahead and talk about what our cylinder is. So volume is our cylinder. We're subtracting a hemisphere. A cylinder is, the volume is pi r squared. R is 3.5 squared times height, which is 3.5. And we're going to subtract our hemisphere, which is 2/3 pi r squared, which is r cubed, actually. And notice that 3.5 squared and 3.5, that's the same thing as 3.5 cubed. So if we have pi 3.5 cubed minus 2/3 pi 3.5 cubed, we are just left with 1/3 pi 3.5 cubed. So we can just write that as one step instead of having two pieces. Try to find those shortcuts whenever you can. It'll save you some time. Oh. So we have 1/3 pi 3.5 cubed. And that'll give us 44.89. We're rounding it to the nearest tenth, so 44.9 inches cubed. This essential question here is asking us a gumball is in the shape of a sphere with a spherical hole in the center. How can we calculate the volume of the gumball? So basically, it is a sphere, but it's hollowed out. And so how could we figure that out? We would need to know the radius of the entire thing, and we'd need to know the radius of the inside part, and we'd do the entire volume minus the volume of the inside in order to figure out what the volume of the gumball part is. All right, and before we wrap it up, why don't you go ahead and attempt this problem, pause the video, and try figuring out the volume of this cone with this hemisphere removed, with the dimensions as shown. All right, and here is my work. All right, I'll go ahead and give you your homework there, and I will see you later on.